Because if you take out a negative 3, you're going to
Okay.
get x minus 2.
Yeah, we can solve this by grouping these two. We can
So then the answer is x minus
take out an x squared. What's left when I take an x squared out?
x minus
2x minus 3. What can I take out of these two?
2.
Right, since that's negative, take out a negative.
What about say what?
Shut up, Josh.
If I divide these by negative 3, what do I get?
2x minus 3.
Okay, remember that if you do it right, these two should be the same. Remember how we did this one?
Yeah.
But yeah, you put the outside stuff in the first parentheses and the inside stuff in the other parentheses. And then what is the answer for this factor? 3 over 2. What are the? Yeah, what's the answers for these factors? So it's x squared minus 3. We want it to equal 0. So you
square root of 3.
add 3. It's not just square root of 3 though. What is it?
A plus or minus square.
Plus or minus square root of 3. Three answers. Cubic function.
Why is it 3?
1, 2, 3.
Oh, okay.
I'm so glad you didn't make us do 11. That's baloney.
You read it?
Dog doo-doo.
Write a paragraph or two in which you compare and contrast the two basic methods.
This is math class, not English class.
That was like a full-out English.
Okay.
Yeah, and I had it right.
On number 10, find all real and imaginary roots of the polynomial equation.
So dumb.
It is spiritual.
You know what? I'm already
10
experienced.
is hard.
I
I
believe
experience.
in the Ishmael and Mom.
Mommy? Sorry. Mommy? Sorry.
Josh, I will let it go.
Alright. Now, this has too many terms for grouping, right? So,
Synthetic.
We can synthetic.
synthetic, what do you mean synthetic?
Can we synthetic divide?
Divide by what? There's nothing to divide by.
Oh yeah, I forgot.
Formula.
No, it's like
The
Oh,
quartic
don't you
formula.
think it's small?
and then you do the same thing. Yeah, find the factors and then you
There you go. We can use rational root theorem.
What's that?
I've never even heard of that.
Oh, it's like the first thing over the last thing divided by 2.
Factors of 4 over
Oh,
factors
yes.
of 3.
Gross.
Factors of 4.
Wait, how did we know that it didn't?
Wait, what is
group?
this?
Huh?
How do we know that it didn't group?
It has 5 terms.
Oh, this is the day I was.
Oh, it's 5. Oh, that's scary.
Why is it not negative? Is it negative?
They're all positive or negative.
Why is it 4 and 3?
All these are positive or negative. So it's 1 over 1, 2 over 1, 4 over 1, which is 1, 2, and 4. But it's also 1 over 3, 2 over 3,
And don't you have to plug it back in to
and
see
4 over
which
3.
one?
Yeah, these are possible answers. If there is a rational answer, it's got to be one of these.
most likely
Let's
gonna be
try
1 or 2.
And does a rational
Let's try
answer
Okay.
make it 0?
Here's the problem though.
Yeah.
I've got a quartic function, so how many answers am I getting? 4.
Possible.
Probably. So remember though, I have to find 2 answers before I can get it down to a quadratic function that we can solve by factoring a quadratic formula. That make sense?
Yes.
Nobody likes this
What do you want to plug in first?
1.
1.
So
Plug in 1, this would be 3.
3 over 2.
3 minus 1 plus 4 minus 2 minus 4.
Matthew, what did you say?
2, 6,
Let's try it.
4.
Oh,
It's negative.
It is.
Is it 0?
Oh,
Yeah,
yeah.
it is. It is. So what did we do? So 1 is an answer. What did we do with that?
Synthetic division.
Synthetic division.
To make sure it's not a double root. Am I right?
Well,
Am I right?
You're right.
we haven't got to that part yet.
Why not? Why are you putting in them?
if 1 is a root, x minus 1 is a factor. If you divide by x minus 1, you put positive 1 in there. Anyway.
Bless you.
Put the root in there.
I have a strong feeling that it's gonna be 3 over 2 plus 1
We're making
I don't think
Oh
that.
wait, it's 10, not
Yeah.
9. I'm dumb.
I thought you were Matthew.
Then you factor by group.
What? That's so intelligent.
I didn't know Austin read.
Oh, you know what? It looks like we could factor by grouping. Wait. Yeah.
Yay.
Good call.
Yay.
Yeah,
And then we
gotta
don't
find
have to
another
put a negative one.
Okay, so Nevaeh noticed that it looks like we're gonna be able to factor by grouping. How did she know that?
Because she's
Because-
smart.
Because these are like at the same ratio, 3 over 2 and 6 over 4. So when we take something out, they'll be the same. Anyway, so I guess we don't have to find another root on this one.
Yeah. Yay.
I mean another, like by guessing. We don't have to do another guessing thing.
Yeah.
Is the baby.
Let's go.
So that has 4 terms, so we can solve that by grouping. So what do I take out of these two?
You take out
X squared.
X squared, I heard you say.
3
Plus, what do I take out of these two?
2.
2.
Oh.
Oh, that's
Good
nice.
for you.
Not sound real.
What?
Just having one of those days.
You got all that ready?
I do actually.
Rinse it all down really quick.
Can you guys finish it from there?
No, I think so. Let me just.
Yes, father.
Here's a scroll.
Oh, yes, daddy. Quadrant?
Joshua.
What's another word for quadrant? Papa?
Okay, try to finish.
So
Ready?
there's
Go,
4.
go.
There is 4.
There are 4 answers, yes.
Wow. Is it plus or minus root 2, negative 2/3, and
Yeah.
1?
What'd you get for this one?
Parental?
Say again?
Legal
Plus or
guardian.
minus 2.
No.
No, I have it.
Three.
Plus or minus I
Wait,
squared.
That's stupid.
You're stupid.
No, I'm Rachel.
Legal
It's
guardian.
like I'm Austin.
You're Austin.
Yeah. The Austin
Or is it
group.
supposed to be plus or minus 2?
I have one.
Just negative 2 a legal guard.
Just negative. The only time you use this plus or minus is when you're doing the square root trick.
Matthew's my
That's what I thought, but you said there's gonna be 4
Matthew's
answers, so I got a little,
The first answer was 1, that thing we did.
Can I do that?
You know, we plugged a 1 in up
The
there.
sum and product of the roots.
Actually?
Actually,
Oh, I was
Sorry.
completely different. We were talking about
Whoops.
What is
something
that?
very appropriate. But we just can't repeat it because I forgot.
Onesies.
We-
Wow, I might like actually not fail.
we.
That's the hard part. If you get that, you get everything.
That's
Wait,
not
where did
fair.
the 1
I
come
don't get
from?
everything.
it was our
That was the first answer.
Oh.
What if you actually did and you just realized it? Oh, number 12, find the sum and product of the roots. Okay, I'm not gonna make you memorize this theorem,
Well, that's
but
nice of you.
we have to use it for number 12, so flip back to page 86.
Do you think I can put options on there?
I mean the last 3 problems.
That's actually 2. But we're good.
Decide.
No, you decide. Okay, so do you guys see where it says sum of the roots?
I'm doing it.
I'm sorry.
How do we do the sum of the roots, guys?
Wait, this is 12, right?
Oh, x squared minus something.
No. So on 12, it gives us a polynomial. How do we find the sum of the roots?
We find the root.
It's on page 86.
The first one.
Oh, is this that awful thing where it's like
Okay,
Negative.
If you look at that big polynomial they wrote, the first term they called a sub n, the first coefficient.
There
they
are
wrote.
5.
So the next one's a sub n minus 1. It's kind of like x cubed, x squared, x1. So when it says a sub n minus 1, it's talking about the second term. So you do the opposite of the second term over the first term. That's what we did. So on,
5 over.
sorry, I should have said coefficient. The opposite of the second coefficient over the first coefficient. So what's the second coefficient? -5. Remember, it could be 0. Remember those couple problems where it was 0? Anyway, -5 over 2. So it's -5 over 2. So that's just 5 over 2.
This is the stuff I
Okay, it said on the Theorem 5 that this is the sum of the roots. And basically this means the coefficient for the second term over, and that's the coefficient for the first term.
That's pretty simple.
And I said, you don't have to have that theorem memorized, you'll be okay without it.
I thought we just called it like.
Oh, we don't have
Are
to
you
do
gonna
that?
give us that?
Is that gonna be on the test?
You don't have to have that theorem memorized. I did put one of these things on the test,
No.
you know, but you just add
Can we
like,
do one of those?
they give you, yeah, we'll get there. We're getting there. That was like the last lesson we did. Anyways, what's the product of the roots? What is,
Negative last coefficient over first coefficient.
Yeah.
If it's odd.
if it's an odd degree, is number 12 an odd degree? Yes. So we're doing negative last coefficient over first coefficient.
So
What do you mean odd
which is
degree?
just
Oh,
-4.
The degree is 3, it's the highest power to x.
okay.
Yeah, it's -8 over 2, so it's 4.
Wait, where'd you get the 2?
The first coefficient. Last coefficient, first coefficient.
And the last one was the middle coefficient.
Last
first one
coefficient
was
was
the sum.
8.
5 and 2.
Yeah, the first one was the sum,
I love water.
the second one was the product.
What number is this?
Oh,
12.
12. Ooh, 12. We basically just looked at Theorem 5 and used what they said to do. So the first part said, if you look at Theorem 5, it says the sum of the roots equals negative. Basically what that means is the second coefficient over the first coefficient.
Sneaky.
And then the product of the roots,
Last one. Not sure.
if the degree is odd, which it is on this one, like x cubed is the degree, then you use negative last coefficient over the first coefficient.
The 8th graders are being really quiet today.
Where did the 4 come
It
from?
might be taking
It
a
might not
test.
be. Oh, yeah.
And then with that, it tastes different.
You should go ask them.
Brady does.
You're not in there?
No.
Brady.
May they rest in peace.
Is that what
That's
they
the
wrote?
only
Why they had
reason
pineapple
why
juice
it's
on it?
quiet.
Oh, what?
Wait, can
What?
we try that?
I want to go
Can we go
outside.
outside?
Can we go outside?
Never.
If we finish,
Are you
can we go
allowed?
outside? No. If we finish the work today, if we finish, can we go outside?
We actually only have 2 more questions. Let's go, hurry up.
No, I need you.
Come
Come
on,
on.
dude.
Do what now?
Hey, can we go outside? if we finish?
No, this ain't
Wait, what are we doing?
Please.
I'll take my pants off. You want now?
Maybe if you would have kept your pants on.
What are we
maybe it
doing?
would've gone
No,
that side.
no.
Come on.
He said we could go to the duck pond to finish. He said we could take it.
We don't have time to go to the duck pond.
I'll take my tails off so we don't have to.
Okay.
Okay, let's just get.
Are
let's just
restricted.
get- We gotta finish doing
Doing
it.
it.
Go.
All right, the last two are basically our last assignments. Find a cubic equation with integral coefficients 3i and -5.
Rachel instructions.
I'm
Well-
not gonna call it that now because I don't understand.
Okay, if 3i was a root,
Negative
what else?
3i.
-3i.
Oh, I remember this.
Okay.
3i, negative 3i, and then negative 5.
Was the last one
And then
negative?
you like multiply
Okay,
like x.
This was the formula I started writing a second ago. Okay, I'm not gonna make you memorize this, but I'll just write this on the board on Tuesday, like up here. But I'm not gonna tell you how to use it either, okay? But it's x squared minus the sum of the roots times x plus the product.
Equals.
It's x minus.
Okay, on this one, it's different from the last one. They're not giving us the polynomial, they're giving us the roots. So this is just for two roots, because it's an x squared. This will just give you an equation for two roots. We could do like x minus 3i times x plus 3i times x plus 5. Like FOIL all that together,
Yeah.
and that would give us the answer. Sometimes, remember though, the imaginary roots were really messy, so that was really hard. So, anyway. You guys remember what we did?
No.
We
I
added
kind of do.
the roots.
We used the weird ones for this part, just to make it easier for us.
That's right.
What's the sum of the roots?
So
No, the three
that
are
would be
plus
three.
0. That plus that is 0.
okay.
So it's just x squared.
What's the product of the roots?
Negative 9i.
Negative 9i squared
Which is
positive 9. So positive 9 goes right there. I just skipped the 0 part.
Is it?
Well,
plus-
where do we use the negative
And
5?
then you.
Okay.
Wait, what would happen with the
This-
x then? What would happen with the x?
This just has these two roots in it. But I still need this root to go in.
Multiply by it.
What's the factor that has negative 5 as a root? X plus
I
5.
agree with you, Matthew.
Thank you.
So if we just multiply those together, we got what we're looking for.
X cubed plus 5x squared plus 9x plus 45.
Yeah, this is kind of like an easier FOIL problem, isn't it? The ones we did on the homework were a little
Last
Crazy.
one.
heftier than that.
Alright, let's go 14 speed run.
Let's go.
Better hurry up, or nobody's gonna beat me up. Is a cubic polynomial pubic square with the coefficient? Explain why an imaginary number. Oh, explain.
Oh, that's not
It's like evil Tigger.
Explain why imaginary numbers.
That's what it sounded like.
Wait, was that the
It's
answer
really
to
not.
number? Was that the answer to number 13, or did we have to like completely factor it through? Just that.
If we factored it, just go back to this.
Okay, that's what I was wondering.
Tiga was the root.
Was it big?
Okay, guys,
Yes, sir.
What did I do?
14. 14.
Guys, wanna go outside?
No, don't.
Wait, what's up?
I'm not gonna read it to you. I'm just trying.
Not mad.
Josh.
Okay.
Josh.
It's not a. It's not trying to trick you. It's not a trick question. You do have to read.
Explain why an imaginary number cannot be a double root of an equation. Because it has real coefficients.
No, because imaginary numbers never touch the actual.
X sided.
Okay, it says it has real coefficients. It doesn't say it has
Well, don't you need
Real.
two?
roots.
Don't you need like two real roots in order to make? one
Why
of
an
the
imaginary
things that
number
makes-
cannot be
I don't know.
Okay.
a double.
Turn back to the theorems.
Isn't it because imaginary numbers don't
What did we
touch the
say?
actual?
Like theorem
I think that's right.
So it can't have a zero.
Theorem 1.
Oh, Josh is on to something.
Oh, is it theorem 2?
I'm on. Not
He's on the
Wink, wink.
It's theorem 2.
wink.
If you guys polynomial with real coefficients, and a plus bi is an imaginary root of the equation, px equals 0. Then a minus bi is also a root.
Yeah, this is a hard question. I take that back. It's
Is it
tricky.
theorem 3?
No. Well, it kind of combines theorem 3 and theorem 4.
So can we just say theorem 3?
No. That's not an answer. That's just the.
Well, then how
facts
do
you have to use.
explain this?
Okay. So
It's getting loud again.
Oh, I see.
if
Oh, if p of x is 1, but it's not under.
If A
Oh, I see, right.
Since it's cubic,
If
it's at an odd degree,
plus
which means it has at least one. Oh, wait, did I get it? No, wait, Mr. Jordan, wait.
Then-
Okay, wait. Okay. Since it's a cubic polynomial, that means it's an odd degree, which means it has to have one real root, and then a complex one has plus and minus, right?
yeah, that's kind of where I was going. If a plus bi is a, let's say, is a root for our problem, then what else is a root?
0.
Negative.
A minus b. I think that was theorem 2.
Yeah, that's what I was looking
Right. Yeah.
But by
Yeah,
theorem,
but then also by theorem 3.
and by theorem 4,
It has to have at least one
you have
root,
to have one real root.
Oh my
which
gosh.
means there can be no double root.
So we got 2 imaginary so far, and
Can I put because of the way it is?
Okay,
no.
let's.
You can, I'll just take one out.
Wait, only 1 point off?
Well, whatever I decide the problem's worth.
Okay. I'll go ahead and write this.
By theorem 4, yeah. What does theorem 4 tell us?
An odd degree has your root.
Has at least one of them.
Has at least one real root.
They're
Oh,
back.
I see. Okay,
So
I see.
piece was.
Yeah.
So what's the problem then? We got 3 answers here. Why do we have a problem?
I have no idea.
Oh, green market.
Because
numbers are floating.
it says explain why the imaginary number cannot be a double root. So
Because they're all taken up.
Yeah.
yeah, if an imaginary answer is a double root, then it would have to be a quartic function.
It would require a function.
Can we just say that all the roots have been taken up?
Hey, there's another.
There's gotta be an easier way to say that.
There's
That's 3 roots.
Cubic polynomial.
yeah. We're just trying to think how to say it best.
There are already 3 individual roots.
And the double root must be 2.
There can be no more than 3 roots in a cubic function. So the imaginary, I'm not sure I said this in the most compact way, but it's a clear way. The imaginary roots cannot be double. I wrote a little paragraph.
For no one.
Wait, we're going upside?
No, I didn't agree to that.
No,
You
please.
did never actually agree to
Mr. Please.
that.
I'll be a
Study
people.
hall.
I'll take off my pants.
Are you trying to threaten me to get us to go outside?
Yeah. Hey, don't you
Is
want
it
some fresh
working?
air?